is that generally speaking, once we talk about the basic parts of the graph, they're graph reading 101. You all know how to read a graph, so for the most part, getting these questions right on the exam should not be very difficult for you. Now, first of all, solubility always has three parts. All right? Solubility always shows the amount of solute in an amount of solvent at a specific temperature. Now, because there are three parts to solubility, two parts have to go on the same axis, which causes a slight issue on the graph. What do you need now? You are a pain in the butt. Has anybody ever told you that?
Yeah.
Good. I hate to be the first person to do it. Now, on the graph, temperature is always on X. So that means the other two variables have to be on Y. Now, the amount of solute per the amount of solvent is not going to be a variable amount. It is always going to be defined as 100 grams of water. It's going to be a fixed amount of solvent. It's not going to change. You struggling back there? It's okay. Take your time. Maybe I should switch to mechanical pencils. I don't know. I might have one if I look. Try not to kill him. All right, everybody caught up with me? No, of course not. You've been sharpening your pencil. Okay, so we're going to have temperature, we're going to have the amount of solvent, and the amount of solute. Now, because the amount of solvent also has to go on the graph, we're going to have it be a fixed quantity. It's not going to change. So all solubility graphs are going to use 100 grams of water. Now, this is one of the pieces where it's nice that you guys already know how to read a graph. So if you have a graph that goes up, you know solubility does what? You know solubility what? Increases. All right. If you have one where the line goes down, you know what? You know the solubility decreases. And if you have one that looks sort of like that, you know what? Okay, solubility stays same. For example, salt. A lot of people think that salt will become more soluble if you heat salt and water. Salt is one of those that is largely not going to change. You can use cold water, you can use hot water. The same amount of salt is going to dissolve whether it's hot water or cold water. Its solubility really doesn't change. Sugar, however, is very soluble if you heat the water. It will become much more soluble. Okay? Everybody's okay with those, right? All right, now we need to add in 3 definitions. I think I have these actually typed. Everybody got it? I'm pretty sure I have these typed, so I don't have to write and y'all all ask, what does that say?
So, like people tell you, ratio off of salt water.
Uh-huh.
So why they tell you do it with hot water instead of cold water? Like, really dramatic.
I assume it's got some kind of healing properties, but it doesn't actually dissolve any more salt. Everybody got what they want? All right. Now, over there. Let me see here. Solutions. Open. There, solubility notes. Oops, go back. All right. That's what I want right there. All right, so on this graph we're getting ready to do. All right, one of the places we have to be able to find is an unsaturated solution. All right, an unsaturated solution is a solution where there is less than the maximum amount of solute dissolved in the solvent. All right, less than the maximum amount of solute is dissolved in the solvent. Hello, Ms. Blackwell. How are you today? That's good. That was pretty good here. All right. So let's say that y'all like coffee. And y'all came over and you decided, I need some sugar in my coffee. All right. And you put some sugar in. What's going to happen when you put that sugar in the coffee? It's going to dissolve. Okay. How do you know the sugar dissolves? Okay. Can't see.
You don't feel it.
All right. Can't see or feel. Now,
It's different if you put sugar and milk.
hold on. All right. Hold that thought. All right. So notice I tried to draw some steam coming off the top. So you can't see it or feel it. So as long as the sugar dissolves, it is unsaturated. Okay? As long as the sugar dissolves, it's unsaturated. All right? So anytime you add anything to a solution and it dissolves, it's unsaturated. Still holding on to Tevin's question. Okay? That's not what I wanted to happen. All right? Now, does everybody have what they want? So let's say that we talk about a saturated solution. Fine. In a saturated solution, you have the maximum amount of solute dissolved in a solution. All right, the maximum amount that can be dissolved is dissolved. No more can be dissolved at this point. So let's say that we went to your favorite restaurant and you order some unsweet tea, or sweet tea, sorry. I know. You order sweet tea. And for some odd reason, yeah, they bring you that god-awful unsweet tea. Of course, Small wouldn't drink any of it, so don't make no never mind to me which one they bring you. Because it's all gross. Any kind of tea. What am I stopping by? I don't know. Tea is disgusting. I'm with you on that, Salma. Anything you have to put that much sugar in could not have tasted good to start with. Okay?
The hook is like this.
That's what I'm telling you. It could not have tasted good to start with. Now, so
Auntie is nasty.
Only tea that's nasty is Hardee's. That's nasty.
Yeah, Hardee's tea is
Hardee's
disgusting.
tea tastes like milk.
all right. Regardless, all right, y'all have lost the point of the example. So we got some tea here. It's unsweet. So y'all, the first thing you're going to do is probably reach for some kind of sugar because you're like, gross. All right. So you put some sugar in it. And the first thing you start to notice is it's probably not going to do what?
It's sinking.
It's sinking to the bottom. And you're swirling your spoon or straw around. And it's not doing what? It's not dissolving. Okay? Now, why is the sugar not dissolving?
Because
It's cold. All right? Everybody knows from other science classes and from home, if you want something to dissolve, you need to stir it and you need to heat it. Those things will make things dissolve faster, right? Which is why when y'all make tea, what kind of water do y'all use?
Hot water.
Hot water, okay? You might add cold water if you want to drink it sooner, but you use a small amount of hot water to get the sugar to do what? Dissolve. Those of you who know how to make Kool-Aid right, do that also and dissolve the sugar first, and then fill it with cold water and add ice cubes. Because if you make it with cold water and ice to start with, where's your sugar all sitting? At the bottom. All right? Now, same thing happens with tea. You go to the restaurant. The sugar's already dissolved if they put any sugar in it. So when you get it and it's unsweet tea and you dump your sugar in and you stir, will any more dissolve? No, it's a saturated solution. So how do you recognize that it's saturated? How can you tell that this is saturated?
If you go to the bottom,
You can see the
You can see the sugar. Okay, so if you can see or feel the sugar, it is a saturated solution. No more will dissolve. The only way you can get that to dissolve now is to do what? Heat it. So your only hope with this unsweet tea at dinner is to stir it up, and when you take a swig is to get a mouthful of sugar with your swallow of iced tea. That's your only hope.
what's S-O-L?
SOLN is solution. Well, I guess you could get a cube in your mouth with it and sort of suck on it with your swallow of iced tea. Okay? But there's no fixing this except hoping you get a mouthful of sugar to go with your mouthful of tea. Okay?
Put half sweet, half unsweet.
Yes, a lot of people do that. They're trying to cut down on their sugar content.
Half sweet and half unsweet.
They're trying to cut back on their sugar. Chances are their doctors told them they're trying to watch their sugar.
just drink water.
That's what they should do. All right, my advice to them is drink water and cut the tea out because it's nasty to start with.
No, it's not.
That's why you're gonna say that, right?
What?
Raspberry tea.
You shouldn't say that.
No, I wasn't actually. All right, the last type of solution is a supersaturated solution. Now remember, we got to find these on the graph in a minute.
What graph?
The graph we just drew a minute ago. We got to put these on the graph. Now, a supersaturated solution is a solution in which there is more than the maximum amount dissolved. in a given solution than would normally be possible. Okay, this would mean there's more dissolved than would normally be possible. So what now? Yes.
What that free cheese did.
Well, what?
That free cheese did. Was good with that large bowl.
Okay.
It's not good for your diet.
I know.
Never tasted sweet tea before.
Yes. I do not like tea. I did not grow up drinking tea, and I just don't like it.
You know, drinking lemonade though, right?
I'm not a big fan of lemonade. I will drink lemonade if I am really hot, it is really cold, but I'm not a huge fan.
I mean, I'm doing pretty well.
But tea, I don't like. I don't care if it's green tea, hot tea, cold tea. I just don't like. I don't like the tea taste. The tannic acid tea taste. I just don't like it.
But you gotta do it. You gotta do it.
Yes, Christ. Alright, so how does this supersaturated solution work? For example, alright, if you could dissolve 10 grams in water, okay, of some compound, alright, and let's just say it was heated to 75 degrees Celsius. That would be pretty warm. It wouldn't be boiling, even though some of y'all told me it was boiling on Friday and had to fix that. When you lower the temperature, if it stays dissolved, when it should not stay dissolved, then it would be supersaturated. A lot of times, when you cool things down, some compounds will precipitate, meaning they'll turn back into a solid. But if it stays dissolved, then it would be supersaturated. Now, remember, you're not going to be asked these definitions on the exam. You're going to be asked about them on the graph. We'll hire a Band-Aid, and then we're going to talk about where they go on the graph. I'm sitting in the chair. Does everybody have it? Do I need to wait? Where are we at?
Give me 1 second.
You need a pencil. Give me 1 second. You got it. Oh. That's what you say.
Right. She's only.
Yeah, because she sees potential.
Oh.
You got it, Rebecca? You got it? When you got it?
She wants you to forget. I think there's something on you, not her.
I didn't tell y'all anything. I'm just waiting on Rebecca.
What do you order whenever you go to a Mexican restaurant?
Depends. No, I don't usually get ACP.
She gets some crunchy tacos.
I go to Mikasa, I usually get some type of shrimp dish. Sometimes I'll get the chicken dish.
She gets some chicken. That's a lot when I
ACP is just rice and chicken. I gotta get ACP or
You got it? All right. So on the graph, I don't need that. I need this. All right. So on the solubility graph. So clearly I've given you a graph that the graph is doing what? Increasing. Now, where is unsaturated on the graph? You need to draw this.
Below.
All right. So unsaturated is below the line. All right. Where am I trying to tell you that saturated is? On the line. Very good. Saturated is on the line. All right. And where is supersaturated? Above the line. Okay. It's above the line. All right, and again, the solubility graph says solute per 100 grams of water. Supersaturated is above the line, saturated is on the line, and unsaturated is below the line. Now, we're going to practice with two types of graphs. We're going to practice with a single line graph like this one, and then we're going to practice with a multi-line graph, because I have no idea which type you will see on the exam. All right. Hurt yourself sitting in the chair? Why is he talking about high school music?
What's crazy is I used to hate that when these school plays because they just played it too much. Everybody like.
Can we pretend you still hate it for a little while and not talk about it?
Yes.
And I'm gonna say, she told me. What I said was,
Yeah.
but you told me to.
Yeah.
It's basically like.
Yeah, the truth. Right.
I could say you were going through the corrections. You pull the trigger. I say she'll pull you do it. I had it going like this and she like pushed it.
All right,
Oh, just like
take your graph. I don't have 8 years for us to do this, so I'm going to help you out, because some of y'all are going to be much faster,
Why not 8 years?
because I just don't today. All right. So, what goes on? X. All right, so we've got to go from 0 to 100. I bet we can count by fives. So 5, 10, 15, 20, 30, 40, 50, 60, 70, 80, 90, 100. Yep, you can count by fives. Now, notice, because some people don't get this when I do this, I counted by fives. So that was 5, 10, 15, 20. I didn't keep numbering 25, 30, 35, 40. I just skipped by fives, right? 45, 50, 55, 60, 65, 70. Everybody see how I did that?
Yeah.
Okay.
Oh, I get you.
Oh.
Just to save my numbering. Now, on the y-axis, I need to get up to 733.
733.
Look at my information on the front. Whoops. I need to get from 122 all the way to 733. All right, 25s is good. All right.
No, 50.
I could do 50s, but I'm going to have to estimate. So 25 is going to be easier for me to estimate than. So again, so if that's 25 and that's 50 and that's 75 and that's 100, do I have to write all those numbers in each time? No, again, skip. So that's 25. So that's 150. That's 175. That's 200. You don't have to actually write all the numbers. 225, 250, 275, 300, 325, 350, 375, 400, 425, 450. So in that sense, you're still counting by 500s. If you were one of those people who's like, count by 50s. I'm still counting by 25s, but I'm only numbering by 50s.
I thought we was 25.
525, 550, 575, 600, 625, 650, 675, 700, 725, 750. All right, so that I label my axes. This is amount of solute per 100 grams of water. And this was temperature. All right, now that we have this, let me shrink this down a little bit. All right, and let it refocus. All right, take your numbers that are here and plot your graph. Plot your graph. Your 0 and 122, your 30 and 216. Plot your graph.
You did it the other way. I did it this way.
You did it what way? That's fine. Yours is just turning sideways. Plot your points.
Wait, what'd you say?
Plot your points.
Oh, there is I did
Zero.
take it down to the slow. If you need me, let me know. 0, 22,
30.
You okay? Got to put this one.
Yep, they're here behind me.
What is like this nice and simple?
Would you stop and please?
Did you connect the lines?
So what is it?
Connect the lines.
Yes.
Got it.
All right, y'all got a graph drawn yet?
Wait, stop.
Water.
It was a freaking cheating, and then once I clicked on it.
You okay back there? I know we got, a gorilla up front of here look like a monkey trying to scratch, but now we got wild animals in the back of the room doing
That's funny. Last time I was one, Miss White said the school
fire and I clicked on it and that happened.
All right, so if we look at what we have here, all right, can we answer question A? What can you tell me is happening to solubility?
Going up.
All right, it's increasing. Everybody okay with that? All right, so in B, estimate the solubility at 35 degrees Celsius. How do we do that? This is where your graph reading skills come in from math class. You don't need special science skills. Find 35 degrees Celsius. What do? Go up to the graph. So find your 35. Read up. And what do you estimate? What'd you get? Find 35. What do you get? All right, mine's sitting at about 250. What y'all sitting at?
You say what?
Mine's sitting at about 250, but what y'all sitting at? All right, so for answer A, here, mine would say 250 grams per what? What do I have to write beside that? How much H2O? Per 100 grams of water.
What are you doing, Miss Wall?
We're doing question B. Estimate the solubility at 35 degrees Celsius. So find 35 on your graph.
Got it.
Okay? Read up to the graph line.
Oh, yeah.
And then read over to Y. What'd you come up with? Yep, where it crosses.
It's 350.
It's
I mean, 250.
250. Now, that's 250 per how much water? What's on your y-axis right here? Per how much water is on your y-axis? What was right here, Selma? What did it say right there? You were supposed to write on your y-axis. Per how much water?
100.
Per 100 grams of water. So when I write my answer down, I have to write 250 grams per 100 grams of water. Okay, I can't just write 250.
Did you put this as?
It's a slash per 100 grams of water. So when I go to do my next one, all right, it's at 55 degrees Celsius. So find your 55 on the graph. All right, 55 up to the graph and over. We're going to estimate this time. So I'm above 400 but below 425 on mine. So I'm going to go like 415. 415 grams per 100 grams of water. Well, the rest of you have. You got 400? Okay.
Like 400
All right, per 100 grams of water.
grams of water.
450.
If it's better.
Yes.
It's 50.
Yes, it is. All right, last one. So 75 would be up to, mine looks like about 550. So 550 grams per 100 grams of water. All right, I want you to try C and D for homework. All right, we're going to do the multi-graph line one tomorrow. We're going to do like dissolves like and molarity tomorrow. What I tell you we're doing on Thursday? The benchmark. Remember, we're doing the benchmark on Thursday because what do we have Friday? Bryce, what do we have Friday?
Your family.
Okay?
Wait, is it in a?
Huh? It's in the morning, but it's going to majorly mess the schedule up.
Good.
So we're doing it on Thursday. That night, I expect a lot of people won't be here on Friday, so we're just going to do it Thursday. So we have it for review the following week. See where some of our short goals are. Oh, I'm sorry. That's why we're doing the benchmark on what Washington.
Right? Are we going?
Say what?
When are we gonna start?
At latest, the Thursday and Friday before the exams.
I'm hoping for
Why she turned it up?
Wednesday, Thursday, Friday.
I don't have to make them in person.
So what now? It would be nice if you could do it like a Tuesday afternoon. Or a- I just said that. I'm doing the test on Friday. I'm telling you, benchmark is first. I'm not saying it's great to do anything that's a missing assignment for you on Friday. The schedule on Friday is gonna be a disaster for second period. The only class that will be even remotely normal is usually gonna be third period on Friday.
Oh,
Okay, which is why benchmark is on Thursday,
yeah.
so that we can have it for review for next week.
Wait, how long is the senior assembly?
Typically 2 hours. It'll be a solid hour and a half.
Is it at the end of the day?
Sometimes it goes as long as 2 hours.
At the end of the day.
No, it'll be first thing in the morning.
First period?
It'll start at 9, so my guess is they'll start calling us 8:40ish. Yes.
So class is gonna be short.
First period and second period will be pretty short if non-existent. Third will probably be pretty close to normal, but I don't know how they'll shift around first, second, and fourth. Say what now? If you ask me tomorrow, when we have more time left in class, yes, or if you're here this afternoon, I'll be glad to share.
Recognize.
Yeah, you got you're right, you're right.
Yeah, you did.
Huh? Well, you need to pick which one you're gonna wear. You're gonna look ridiculous with 4 tassels on.
Found my open, so I'm missing two.
Say what now?
I found my open.
Oh, good. Stay home and put them up there where my phone is. Now take care of it. Because 8 is a whole lot better than none.
But isn't it like an honor test?
Oh, you missed the test too? Okay.
Either today or tomorrow. Possibly tomorrow. I have a lot of tests.
Just, they're on our test correction.
I'm telling you no.
Oh, okay. That's fine, whichever day.
How many quizzes do you have?
Come on, 4 or 5.
4 or 5. That's good.
Alright.
That was wild.
I'm
Sierra Gordon, come to guidance, please. Sierra Gordon.
Call me. Miss Wall, if I get a from Johnson, can I take my test like your turn?
If you get what?
I know from Johnson.
Yes. That'll be fine since you missed his class or you missed my class because of his class, that'll be fine.
I mean, we're doing nothing in there anyway, so I mean, all we're doing is just like chilling. So.
If he's fine with it, it's fine with me.
Yes, ma'am.
One less of you I gotta deal with after school. Oh, man.
Hey.
Thank you.
Miss Wall, can I call a mom right quick?
Just stepping back. You need to off your phone, Kim? What's last? Hey, Bryce.
Yeah, look.
I ain't late today. Oh, no, bro.
No.
Oh, bro.
Alex is an asshole.
Guess what? Guess what? Yeah.
But like, you're watching Enemy of the State in second period. We're watching Enemy of the State
That was
in
not
second
me.
period. Alex was trying to ruin it the entire time.
Hey.
Having a what?
He was trying to ruin it the entire time.
Okay.
What's Alex?
Like every time Jack Black showed up on
Look who's
the
talking.
screen, he tried to sing.
That's not smart.
Hey,
What's the
tell-
shirt?
We weren't, no.
No.
Let me say, only Alex.
No.
Nobody would.
I can't the central. Why you laughing? Hey, girl.
That definitely is a better excuse.
You were talking to T.
Who did she came from them too?
I was like, she coming for her my birthday.
I can't come in happy.
I bet you said no word. Miss Wong.
I was just killing the boy.
Are you too late? We said because you're talking to people, a teacher.
I said, she was like, no, maybe we still. I said, okay. Y'all, Zip, his grandma looked just alike, bro. I swear to God. He sent me a picture yesterday with his grandma in the cut, boy. I swear to God, they was making
Well, she was about ugly now, we wasn't. She was looking at her phone and she got blind, she didn't have her glasses, she was like.
So that I don't have to yell at y'all when y'all yell.
He looked just like his grandma. I don't care what he said. I mean, you already in a bad mood, so ain't no point in me yelling. You like this all until the end of the school year.
Miss Wong, sorry, you said, can you tell her what about look?
No, you got here late. Sure.
Can I fill it up?
No.
Good. I thought you had an ice pack, you okay?
Hey.
Baby, you know that I miss you, I wanna get with you.
Where you been, Kim? Huh?
I just wanna
What you think? Oh, I had to stay home, wait till the cable man, because I can't deal without the water. Huh?
Hey, my jumper, right? We're like, sing it, sing it.
I can't deal with that.